The trigonometric function, particularly sine function, is a frequently discussed topic in mathematics. Today, we'll delve into the inverse function of the sine, considering the perspective of passing the horizontal line test. To pass the horizontal line test, we restrict the domain to -π/2, π/2, resulting in a range of -1, 1. When symmetrical shifting is applied to this function with respect to the line y equals x, the inverse sine function is graphed. The inverse sine function has a domain of -1, 1, and a range of -π/2, π/2, as constrained by the original sine function. This relationship becomes evident when both functions are plotted on the same coordinate plane. Now, let's explore transformations of the inverse sine function. Consider the graph of y equals 2 arcsine, 1/2, x minus 3/4 plus pi. Firstly, plot the parent function y equals arcsine, x. As we've done before, this should be straightforward. Secondly, graph y equals 2 arcsine, x, representing a vertical dilation by a factor of 2. Thirdly, plot y equals 2 arcsine, 1/2, x, showcasing a horizontal dilation by a factor of 2. Please note that it is by a factor of 2, not by a factor of 1/2. Next, graph y equals 2 arcsine, 1/2, x minus 3/2, representing a horizontal translation 3/2 units to the right. When factored, the coefficient 1/2 in front of x becomes 1/2, x minus 3/2. Please note that it is 3/2, not 3/4. Finally, graph y equals 2 arcsine, 1/2, x minus 3/2, plus pi, which corresponds to a vertical translation pi units upward. As observed in the graph, the final function has a domain of -0.5, 3.5, and a range of 0, 2 pi. Let's review the entire process of transformations. Understanding the restricted domain and range of inverse trigonometric functions makes visualizing their transformations more manageable. Many students find graphing inverse trigonometric functions challenging, but with a grasp of the restricted domain and range, understanding their transformations becomes surprisingly straightforward. See you next time.